Dear students, today we will discuss electric field. What is electric field? Suppose this is a charge Q, then what will be the electric field? So electric field is nothing but the region around, yani the area around this charge within which the influence of this charge may be experienced. Means suppose the influence of this charge can be experienced within this, so then this whole will be electric field of this charge. But what will be the intensity of that field at point A and at point B? Will it be same? क्या सेम होगी? यहाँ पर इसका जो इन्फ्लुएंस होगा और यहाँ पर जो इसका इन्फ्लुएंस होगा, क्या वो सेम होगा? जी नहीं होगा, बिल्कुल ठीक. यानी the influence at A will be intense और at B कहाँ पर ज़्यादा होगा? Which is very close to charge. So at A the intensity will be higher and at B the intensity will be low. It will be less intense. It will be highly intense. So then we can define electric field intensity. Electric field intensity E. It's a vector quantity as force. So if we bring a charge over here, then it will apply certain force of interaction, maybe attractive, maybe repulsive. If the charge brought here is positive, so this will repel, and if the charge brought is negative, then it is going to attract. If the same charge is placed at B, then this time the force of interaction will be less or higher. So of course, since the distance is large, so the force of interaction will be less. So the intensity can be defined as the force experienced by the charge at that particular point. But if we don't define it or set it a particular scale, then this intensity will be different for different situations and by different person. So which will create a confusion. So for that we have to make it standardized such that, or unique such that the charge should be same here. Suppose I bring here 4 microcoulomb and here is 1 microcoulomb and then I test, then force may be more here than this, or force may be less here than this if it is 8 microcoulomb. So that means this way the conclusion will be not a correct one. So what is to be done, if we are comparing and if we are deciding it, then the charge, the magnitude of the charge must be same. So if you take 4 microcoulomb here and 4 microcoulomb here, then that time you will compare. So definitely here the force will be large as compared to this. So why 4 microcoulomb, why not 5 microcoulomb, why not 10 micro? Again there will be problem. So the best thing is to make it one unity, yani unit charge. And that unit charge is known as test charge and we denote it by Q naught. So electric field intensity can be defined as it is the force per unit test charge. Now further, if suppose you don't bring any charge over here, does it mean that there will be no force? That means there will be no intensity of the electric field? Whether you bring a charge here, test charge or any charge, still the electric field of the charge is there. So that means even if limit Q naught tends to 0, this electric field intensity is force per unit test charge. So that means if you bring a test charge Q naught here and the distance of this charge, we will take it point charge, is R, then it will be limit Q naught tends to 0, Q naught upon mod R square unit vector R divided by unit charge, then that will cancel out. So after taking limit of Q naught, you will get KQ R unit vector divided by R square, and that can be written as KQ R complete vector divided by mod R cube, as R unit vector is always equal to vector divided by its magnitude. So this will become R cube. So this is the electric field intensity at this point. You can write it ER. Now, if the charge is not placed at origin, because we are taking it as an origin, ये ऐसा origin ले लिया हमने, इसीलिए इसका position vector क्या ले लिया हमने, R ले लिया. But if the charge is not placed at origin, it is positioned somewhere else, then what will be the formula for that? So, in that case, if our origin is somewhere here and the charge is Q1 here, Q here, and the point is here, so that means this is your R1, you can say, and this is your R. So the position, the distance will be considered this one. So this will be R minus R1 vector. So in that case, this E R will be nothing but KQ R minus R1 vector divided by R minus R1 mod Q. Because the distance is to be taken from the charge to the point, and here its position is R1, its position is R, so this vector will be equal to this minus this, tip minus tail. So tip is R and tail is R1, so it will be R minus R1. Now we can find the direction of electric field. Where will be the direction of the electric field? For that, we have to know about the electric lines of force. Suppose, what is electric line of force? Or in this case, what is the direction of the electric field and where the direction of the force? If it is positive and you bring a positive charge Q naught here, so this force or this charge is going to repel this, so this will be the direction of the force, and so will be the direction of the electric field. So direction of electric field, if Q is greater than 0, that means positive. So electric field intensity will be outward, and if Q is less than 0, that means negative, then electric field intensity will be inward. The direction of this electric field intensity will be inward. Suppose this is the negative charge. So this time what will happen? It is a positive test charge, so it will pull it. So in that case, the direction of the force will be here, and so will be the force of electric field.